we have three panels there. So the first panel, within the first panel, where file names are present, we can create a file name. We can create directory name. So in the second panel, we call it as an editor. So within that particular editor, we can write program over there, and then there will be a third panel. So within the third panel, where we can see the result. So we can give the parameters, we can execute there. So at the same time, we can see the result. All right. So that is what we can observe with the help of this online compiler. Right? So we'll see about that currently. Uh, so here you are in a position to see my desktop. I shared my desktop. You can see the online integrated environment browser. Here there are 50 plus language editors are available, so we can have those editors. So most of the case, at this present, what editors are required for you is, it can be a bash, or it can be a C, or it can be a Python. So you can have a Python also. At the same time, here if you type a bash, you will get a bash. So here at present you go for C editor, right? So here create C editor. So you will get the panel like this. So here you can see the Ubuntu operating system, right? So the Ubuntu operating system. So you can have C programs within the Linux environment. So we can run that particular program. So you can see the result over this particular environment. Right? So here this is a directory. So the present working directory, we can say, in this present working directory, all the files which you create, so it will be existing in this particular directory. There will be a next panel. Next panel here, we call it as editor, right? So the text editor, where we can type a program over here, and then we can run. So there is a run button is also available. So if we run, we can have the result in the third panel, right? So this is environment we can see in this particular website, right? So here I have a simple program, right? STDI include STDI mode of which into main, right? Printf hello world, right? Return 0. So here just I'm trying to print hello world in my terminal, right? So here I included a header file, I included the printf statement, right? We type a normal C program over here. So the C program which we typed, so it is going to be executed, right? How we are going to execute this C program here, we'll see, right? So how we are going to execute this particular C program, we'll see here. Here just see, the name of your program is main.c. The name of the program is main.c. It is available in my present working directory. So this is my present working directory. So just go ahead for running this program. Here I can run this program. I can click this particular button, or I can type GCC, right? GCC indicates that so the C in Linux compiler, the C compiler in the Linux environment. So we call it as C compiler in Linux environment. So followed with a space, my program name main.c, right? So just I'm typing here. So immediately I got a prompt, right? Just see. So when a program is executed, I get a prompt, right? So when I got a prompt, if there is a no error, so within my current working directory, there is another file which is created. so which we call it as a dot out. We call it as this is an output file. So here within the Linux environment, so if it may be in our computer lab also, if you practiced, or within your desktop computer also, if within the Linux, like if you have a Linux operating system, when you type a program by using a V-editor, you go and compile within a prompt. So GCC is followed with main.c, right? You try to save that program, you try to save that particular program with the .c extension. You save that program with .c extension. After saving, you can type, you can execute that by using command gcc followed with main.c, right? So your command gcc will try to execute this c program within the Linux environment, right? If there is no error, so immediately within my present working directory a dot out file will be created, right? Here if I execute this, if I execute a dot out and then I get a result, right? How we can execute this a dot out means the same error, dot slash, so a dot out dot slash a dot out. Press enter, so I got a result, hello world, right? So I got a result. So this is a way we are going to execute the C programs within the Linux environment, right? So dot slash a dot out, so this is the output file. So when it is compiled, when there is no error, so output file will be created in your present working directory. So here, you can uh, you can execute this within a font. So here you need to type dot slash slash a dot out, right? So dot slash a dot out, right? You will get a result. So this is a one example, right? So in the same manner you can have so another programs, so 7a, right? So hash include stdio.h, hash include uni stdio.h, you can type all this, right? So go for hash include um, hash include um, uni stdio.h, hash include, right? Uni main followed with process ID. So you can go ahead typing your program. Um, you can type all the program continuously like this. So and then you can execute that. So here one thing you need to remember. Okay, so here just see the seventh exercise, fourth system call. Here we like to print what is a parent process ID, what is a PID of a parent process. So what is a PPID of a parent process? So what is a child process ID? So what is a child what is a child process ID, PPID? So these two things we like to print with the help of this program. So here you can see PID is a just see here we are using the printf statement. I am original process with the PID percentage D and the PPID percentage D get PID. So get the PID is a function. We like to get the process ID, right? So and then get the PPID is also a function where we can get the original or parent process PID, right? Parent process PID, right? So we are using these two functions within the printf statement. So here forking, right? Fork function whenever we need to create. So whenever we need to create any process for creating a process, so we use a fork system call. So here fork when we fork, so it will have a process ID. So I'm storing this particular process ID within the variable. We call it as PID. All right. So we are going to have this process ID. So here we have a condition if PID not equal to 0, right? So enter. Most of the case PID is not going to be 0. PID will be as a value, right? If it is if statement got true, so enter into this particular loop. So here in this particular loop, so we have printf statement in order to get the process ID of the original process. So at the same time process ID of the parent uh, process ID, all right? So and then printf the child process ID. So this is what we like to print. So and then finally I need to terminate, right? So this is a simple code. So here we are going to type compiler in order to execute main.c. So my program name is main.c, right? Main. Before going to this, you try to use GCC compiler, GCC space main dot c. Immediately it will get a prompt. So whenever you are getting a prompt, you can see a dot out output file will be um, present in my our working directory website, right? So and then go for running this output file a dot out. If you run this particular a dot out, so there you are going to get so what is a process ID, right? So what is a original process ID means what is a parent process ID, what is parent PID, and then what is a PPID, right? So parent process ID, all right? So both will be displayed, and then the child process ID, the child process ID will be a 112, and then it will be terminated. So this is output we can see from this particular exercise, right? So um, right, this is 7A. You can execute a program like this. So GCC space main.c. So the same procedure you can follow in your computer also. Within your computer also, you use a GCC space main.out, right? So it will execute immediately. You will get a prompt. So when the prompt is not displayed, So there will be some errors. So errors in which line it will be displayed. So and then we need to modify those errors, and then immediately we'll get a prompt, and then when you get a prompt, it indicates it within your present working directory. So the output file will be generated. So by default the output file will be a dot out for all your C programs, so which you are running in your Linux environment. All right. So here you need to identify this and execute that a dot output file. For executing that dot slash a dot out, if you press this, so meaning is it is an object file. All right. So we can say that it is an executable file. So if you run this executable file dot slash a dot out, so and then you will get result. All right. So this is about 7A, and then 7B. There is a simple thing in a 7B, right? So here also we are getting process ID. We can create a number of process by using a fork, right? So let's see. Right. Okay. So here, let's see here. Coming to 7B, create a chain of process. Here, a program for creating a chain of process using a fork system call. So I need to create uh, more number of process, right? So the chain of process. So here in order to create more number of process, here the thing is uh, we use a fork system call within your inside the main function, whatever may be the number of times you require, right? So fork, fork function, a semicolon, fork function, semicolon, fork function, semicolon. So like this, if we type, so every time it will go for this, it will call this fork function. So and then go and print what is the process ID of this fork, and then goes another fork, again it will print the process ID of that, again it will call the fork system call, again it will print. So like this. So we have process ID. We are going to get the process ID of each process. So when it is called by using a fork, right? So when it is called by using a fork, right? So just in the same manner, so we like to execute main.c, all right? So here I have a main.c in function. There are one or two warnings are there, so we are not bothering about warning, all right? So I got an output file a dot out. So run this particular output file. So here, so I can see the result. So by using the fork, so it is creating a more number of process, right? So it creates a more number of process. So whenever it is forking, so every time, so it will try to, for each fork, it will generate a one process ID, right? So that process ID will be printed here, right? So here every time get PID of a process whenever fork is called. So and then get PID of that particular fork. So whenever fork is called, again get PID. So like this. So the program will work. So this is about uh, a 7B for creating a chain of process. So like this, we can execute. Like this, we can execute program which is written in a C language. So in the Linux environment. So here, whenever we need to execute, we need to type, right? If it is in our computer lab, so we use a editor, VH space program name dot c, right? VH space program name dot c. We type a program, print escape, and then control colon right quit, right? We are quitting from v editor. So that file will be present within your current working directory. So and then go for the prompt. You can type a pwd present working directory, or you can type ls minus cl. So ls minus l. So if you type ls minus l, you can see whatever may be the file which is created by you. So immediately whenever you are typing, whenever you are compiling, or whenever you are executing that file, so there may be a chance it may not get executed, because when a file is created, so when a file is created, it may not have execute permissions, all right? So that's the reason we need to type ls minus l and then see what permissions are available for the owner, all right? So by default there will be a read write, so there may not be an execute, right? So if there is no execute permission, so and then we need to use a ch mode, change mode, and then permissions execute plus owner, right? Ch mode space x plus o space file name, right? We need to change execute permission. We need to apply the execute permission for the owner. So and then again we can type gcc space program, and then your program get executed. When you get immediately a prompt, immediately if you get a prompt, so it indicates that program has no errors, and then a dot out file will be present within your current working directory. So and then you can execute that within your prompt, starting with current directory dot. So dot indicates that it is a current directory. In a current directory, so there is an executable file, we call it as a dot out, dot slash a dot out. We are running that, so you get executed, right? So this is about program, which we call it as 7B, right? So like this, uh, we can execute all the programs, right? So you also need to practice once again, all right? So already I practiced ninth A also completed, uh, 9B, 10 already I covered earlier. Just see 10th one again, it is C program. We'll see how it get executed. uh, at 10. Well, right. So go for 10th one. Again, printing environment variables. How we can print the environment variables. So what are the environment variables within your computer? Means within your operating system. So there are so many environment variables will be there within a computer. Here, the environment variables slash home is an environment variable. Slash USR slash bin is an environment variable. You can see in the right side, right? You can see the right side. So this is this and all we call them as environment variable. So home is a variable. So within the home, I have a home slash runner. So in our computer, so the path will be not like this. So runner is a username. So runner is a username here. So home is a directory, right? So under the home directory, the username is runner, right? So currently, my username or you if you work in your computer or in your mobile, so you may get in the same manner. So it may be a runner or something else, right? So here you can see the host name for EBC like this. Here, so these are and all we call them as environment variables, right? So environment variables within your Linux operating system. So you can see the x86 Linux GNU, right? So this is currently the Linux version i386 GNU, right? Here in your computer, so the path majority of the content will be the same. Some extent the usernames get varied. So you have your own username. If your username is a root, so you will get a root, right? So and then has apt slash user slash bin. So this under some extent may be similar, all right? So like this we get the environment variables, right? So this is a one example for illustrating printing the environment variables. So those are the variable environment variables which is a part of your operating system. So I can have my environment variable. I can know what is the environment variable for my current working directory, right? So what in each environment variable, my user credentials is stored. So we can see from this particular file only, right? So from this particular files only, so we can see all this identity, right? Uh, this is about one program which is a part of 10, right? So like this, you try to practice, all right? So you try to practice all the programs once again. Um this is editor IDE environment. So for today's class end, so I will practice in the next class remaining part. So like this, uh, uh, we are going to execute our laboratory programs with the help of this type of editors. We practice well. This is mandatory whenever you come to the college directly there will be an exam. That's the reason, right? So is there any doubt? Hello, hello. So anyone
Sir,
can,
no doubt, sir.
huh? So
No doubt, no doubt.
have you practiced
Yes, sir.
ప్రాక్టీస్ చేస్తా అన్నారా ఇది? ఎడిటర్ ఓపెన్ చేసి మొబైల్ దగ్గర చేసుకోవచ్చు. మరి
Yes.